In this lesson, we're going to learn about re-rendering CG images from our 3D applications to the format that NUKE prefers, as well as efficiently using our channels. So I've just opened up 10_begin, and we're starting with a frame from our Infiltrator project. Now, this frame is directly out of Maya, so it's actually formatted incorrectly. Maya creates EXRs that are tile-based. So it renders out a cube or a tile of the image, and then once it finishes rendering that tile, it moves on to the next tile. And the file format, or how the file is set up on the actual hard drive, is set up in exactly the same way. Now, on the other hand, NUKE prefers scanline EXRs. So that means the EXR is stored, each scan line, or every single horizontal line, is stored in order. So the tile and the scan line are very different EXRs, although it'll be difficult to see. There will be a speed difference, but again, it's difficult to find that information. But the rule of thumb is if it's directly out of a 3D renderer, it's going to be tile-based. If it's out of NUKE, it's going to be scanline. And again, NUKE likes scan lines. So whenever I render something out of Maya, I usually bring it into NUKE and then just re-render it out into the EXR format. And that just assures me that the file is in the format that NUKE prefers. So again, I'm just going to type in something into my write node here. And it prefers a zip scan line, either 1 or 16. 16 is going to be slightly better for CG because, again, there's a lot of repetitive elements and a lot of empty space. Now, if you're just doing a straight write, make sure you choose the channels you want. Usually it'll be RGBA, but in this case we have a lot of channels, which is also a problem. But we also have a bounding box that does not need to be the entire frame. If we hit A, we can see the alpha channel, and we're really only interested in this small area here. So if you have not set your bounding box out of your 3D application, and I'm not really sure how many can, you can always come in and as you're rewriting this EXR file, turn on auto crop. And that will set the bounding box correctly according to which pixels are being used by this image. And so now we essentially have a good setup to re-render CG images. However, again, we have this problem with the EXR file format, or the EXR file format is slower based on how many layers we have inside of it. So right here we have about a dozen layers, and so if we try and access the shadow draw layer, it's going to be much slower than if we had rendered each of these channels out into their own file sequence. Now you're going to have to make the decision whether the increased compositing and rendering speed inside of NUKE is better than having a more organized file structure. With the deep EXR workflows, you only need one EXR sequence for all of these layers. Now, if you break all these out, of course, we have many more files, but it does process, let us work inside of NUKE, and render much quicker if NUKE can get direct access to each of these channels. So when presented with this situation, I usually shuffle these channels into slightly nicer name than the Maya defaults. Glow Raw, Spider Glow, 26 blah blah blah. It's not really human readable, so at the least I always drop in a couple shuffle nodes and shuffle these channels into either the RGBA or a more nicely named channel layer. Now let's just talk about the difference between shuffling it into the RGBA and then rendering out the RGBA versus shuffling into a new channel layer that is custom named. So in the second shuffle node, let's come down to new and we'll create a new channel layer, and let's call this, let's see, this is going to be the glow, and let's just auto RGBA. I don't think this, well, it looks like, well, I don't think it has an alpha channel, so let's just create it RGB. And let's plug our glow raw into this glow port. And this is what I usually do if I'm going to be staying inside of NUKE. So again, let's take a look at the difference between Shuffle 1 and Shuffle 2. Shuffle 1 is very good for very mixed pipelines. For example, if I wanted to use Photoshop on this, I would stick everything into its own RGBA container so that Photoshop can read and write to it correctly. Some applications like Photoshop and After Effects have a little bit of difficulty getting to these custom named channels, and they don't really know how to deal with them. So if you're using a very mixed application pipeline and you're going outside of NUKE for essentially anything, split apart each of your channel or each of your render layers into its own RGBA and then just render it out with the correct name. So in this case, this would be our glow dot, say %0 3D for some spacing. And then we would do the exact same shuffle workflow for all the rest of these channels. Now, as you can see here, this is a little time consuming, but we can actually save some channels because a lot of the data that we get out of Maya, or some of our channels or images, are actually more data-centric than they are RGBA. To see what we're going to do, let's actually drop in a shuffle node here, and let's plug this in, and let's just take a look at these ambient occlusions. All right, so we have our ambient occlusion soft. If we look here, and this is in the RGBA, and all three channels are exactly the same. If you type RGB, not spacebar, but RGB, you're not going to see any difference. The same can be said for our ambient occlusion tight. RGB is exactly the same. Now our camera depth is again slightly different. It looks like nothing, but we can see the camera depth raw data is in the red channel. So again, what we're looking at with all of our ambient occlusions and our shadows are single channel data. So what we're saying is that we can plug a number for exactly of these single channel data into the RGBA slots, and then instead of creating 4 different files for these 4 passes, we can instead just shoot them out in a single file and then use the RGBA to edit with later. So that would look like, let's see, go to our shuffle 3 here, let's grab our soft and let's say our tight, and we'll plug the soft into red, the tight into green, and we're done with this one. So we'll need another shuffle node. And let's see, let's plug the RGB of the red and green, because again, we're using those channels already. And this time let's grab the shadows and plug the B channel into the shadows. So if we look at this and we reset our viewport to RGBA, we can see a very strange image appear. However, if we look at each channel individually, we can see what's going on. If we hit R, we can see, oh, okay, that's going to be one of our ambient occlusions. G, okay, that's going to be our tighter ambient occlusion. B, oh, that's our wall shadow. But all of this is stored inside of a single image. And finally, we can add one last shuffle to shuffle our depth, or another shadow pass, into the alpha channel. Actually, let's shuffle, make sure we keep our original channels, and then we can shuffle our depth into, finally, the alpha channel. So now we have, with this one pipe, and if we just write this out, we would have 4 layers in one file. And this is okay to do with an EXR because we're essentially just breaking or combining data and removing unnecessary data. So again, we have the red channel, which is the soft ambient occlusion, the green channel, which is the hard, the B channel or blue channel for the wall shadows, and finally the alpha for the depth. Now, of course, we have to be careful because just bringing this in and doing our normal operations would not work correctly. We have to make sure we deal with this multi-layer EXR file correctly. But again, this is just another way we can minimize the number of files we create while also minimizing the wasted data that NUKE is having to slog through. For example, I mean, if we look at the ambient occlusion, it's having to process 3 full color channels of data for really what amounts to 1 color channel of data. So by throwing 2 channels away and just keeping 1, we're going to be working much more efficiently and be able to work and render much quicker because, again, NUKE is going to have access directly to the data it needs. And that's pretty much it. Once we've rendered out or written out all of these channel layers, we can bring them into a new comp and begin compositing quickly here inside of NUKE. So again, let's just do a quick recap. Normally, rendering out EXRs is what we need from our 3D application. However, most applications or some people still work with a deep layered EXR file. And this slows down NUKE considerably, especially when dealing with small data sets like the incandescents here. This would take forever to load up if we did not break it out. not only because it has a bounding box of the entire frame, but also because it's nested deeply inside of an EXR file. So if you can split apart your passes at the 3D renderer level, that's one less thing we have to do in NUKE. However, I would still recommend bringing these into NUKE and writing them out into their own passes. Again, using auto crop and the built-in 16 or 1 scanline compression type, which is going to, again, show a marked improvement in your speed inside of NUKE. Finally, we talked a little bit about how we can maximize our use of channels by identifying single channel data like ambient occlusion and depth and raw shadow passes or normal shadow passes. And by bringing all of these together and then outputting them into a single file, we are efficiently using NUKE's limited resources. So all of this information, you could ignore it and continue working as you have, but if you'd like to work quicker and be able to create much more revisions and create a much better final shot, take a look at these techniques to speed up your own projects.